Welcome friends to this tutorial where we are going to talk about dependency inversion principle. So this is going to be the last video of this series on solid design principles. In previous videos, I already have talked about single responsibility principle, LISCO open closed principle, LISCO substitution principle, and interface aggregation principle. So if you guys are interested, you can go back and watch those videos. The links are there in the description. Yeah, let's start with today's topic, that is dependency inversion principle. So let's begin with its official description. So we go back to the previous. Yeah. So dependency inversion principle. The dependency principle consists of two distinct statements. Yeah. The first one is high-level modules should not depend on low-level modules. Both should depend on abstractions. Okay. And the second statement is abstractions should not depend on details. Details should depend on abstractions. Okay. So these official descriptions are a bit difficult to understand. So in next slide, I have written the same thing in the simple terms. So this principle says that we should aim to reduce coupling between components by introducing abstractions. Think of interfaces between them. What it is actually trying to say is, suppose you have different classes in your project, right? So the different classes should not depend directly on other classes. Suppose you have class A and class B and class C, etc. So class A should not directly depend on class B, or class B should not directly depend on A or C. So you need to try decoupling between these components. So if there are dependency, then these are tightly coupled, right? So we need to aim to reduce the coupling between components by introducing abstractions. How we achieve abstractions in Java? Using interfaces or abstract classes, right? So what this principle says is, use means your classes should depend on abstraction instead of concrete classes. Or in other words, classes should not depend on each other directly. See this statement. Yeah. Classes should not depend on each other directly. So let's try to understand it with an example. So I have written an example in my Eclipse. So I'll try to explain you through that example. Okay. So in my example, I have class called HTML report writer. Okay. First of all, I have a class called report, and this is just assume that this is an report. Okay. So this is not an ideal report, but you just need to assume, because my objective is not to implement it properly. I just want to just a dummy example kind of thing that I'm using to explain you dependency inversion principle. So you assume that this is a proper report, okay? And this is having an ID and then report data. Report data is string, okay? And then this class HTML report writer is responsible for writing this report. You will give a report to this method, and this class is responsible to write that particular report into an HTML file. Okay, that's why it is called HTML report writer. So I have not written the business logic of writing that report to HTML file. That I have commented that piece of logic in the to do, because the objective of this video is not to explain you how to write a file into HTML, right? I just want to explain you dependency inversion principle. That's why uh, I'm using these examples. So just to make sure that this method is getting called, I have used this system.out.println and that prints some message, okay, just to make sure whether this method is getting called or not. So this is the report class, then we have a HTML report writer, then we have this another class called report generator. So the report generated class is dependent on this HTML report writer, and it uses its write report, this method write report to HTML to write this report into an HTML file. So the objective of these two files are same, is writing the report to HTML file, but this is the class that is actually writing the HTML report into HTML. And this method is calling this HTML report, using this HTML report writer to write this report into the HTML file. You see, this class is directly dependent on HTML report writer. Okay, and using this object of report writer, it is calling write report to HTML and passing this report object. So, and we have another class called client, means we need to invoke these methods from somewhere, right? So to invoke these methods, I have written a client class that is having a main method, and in that main method, I'm creating an object of report generator class, this class. Okay, I'm creating an object here, you see, using new operator, and then I'm creating a report object because this method, this generate report method takes a report object as its input, right? So that's why I'm creating this object, and using this object, I'm calling this generate report method and passing this report as its input. Okay. So let's run it and see the output. Okay. See, it is printing dummy report data written to HTML. How it is printing this? When you are calling this method here, right? So go to this implementation, and this method again calling this write report HTML from this HTML report writer class. So go there. So here you see it is printing this statement, the whole statement. So the whole design is doing its job. Okay? It's writing the report into the HTML, but this is not a proper design. This is not an ideal design because this is not following the dependency inversion principle. Why it is not following? So as I just in the slide, we saw that what it said, the classes should not depend on each other, right? But in our example, this write report generator class is directly dependent on HTML report writer. These two classes are tightly coupled. Report generator and HTML report writer. Without this HTML report writer, this report generator class won't be able to accomplish its job, right? So these are tightly coupled. So that's why here it is, breaking the principle of dependency inversion principle, because this class is directly dependent on this, right? So this is the first problem. Then again, it is having another problem. So this is breaking single responsibility principle as well. So you see here, it is creating an object of this class using new operator. So this class is doing two jobs. First of all, it is creating the object of HTML report writer, and then second, it is writing, using this object, it is writing that report into HTML file. This is doing two jobs. So let's refactor it. So first of all, this is the first problem. So let's refactor it to reduce. This is first problem. Okay. So let's refactor it. So now this is just using the reference, but it is not creating, it is not actually creating the object using new operator. Okay. So how the object will be created? So because this report generator class is being called from here, client class, so it's responsibility of the client class to give its dependencies. Okay. So let's create a constructor here. So generate generate constructor using field. Okay. So now this class report generator is not creating the HTML report writer object anymore. This is asking its client to give me an HTML report writer using its constructor. Okay, that's why this client class started giving an error, because initially we were not passing anything from here. So now this statement needs to be copied here. Now the client class will create the object of HTML writer and pass it to the report generator class using its constructor like this. Okay. So the first problem is solved. Now let's run and see the output again. See, it's giving the same output, right? But now what you did is, now this class is not responsible of creating the object of this class. Whoever is using this report generated class is responsible for creating the HTML report writer object and giving it to you. Okay, like this. This client is creating the object of HTML report writer and giving it to this report generator class from using the constructor. So you solve the first problem. Now this particular class is doing a single job, only writing the report into the HTML file. But still, we have not resolved that dependency inversion principal problem, right? Still, this class is report generated class is directly depend on another class, that is HTML report writer class, and this is a violation of dependency inversion principle. So now let's try to solve this problem. So what happens? What is the problem if you are not following dependency inversion principle? So suppose initially client gave you a requirement that the report needs to be written into HTML file. So you written this kind of code. Okay, currently you are writing the report into HTML file. But after some time, like maybe after a week, month, or a year, client comes back to you and says you that please write this file, this report into an CSV file instead of HTML. Or the client can say you write it to both the formats, even HTML and CSV both. Then you will have to make changes into this class, report generated class. Now you will have to, first of all, you will need to create another class, something like this, like CSV report writer, and then you will have a dependency of that new class over here in this report generated class, and you will basically you will need to make lots of modifications in this class as well as the unit test of this class. Even you will have to recompile this class. So your code is not maintainable. You'll need lots of modifications to maintain your code, or to add additions in your code, and even your code is not readable. So to get all these benefits, you need to follow that dependency inversion principle. So let's try to implement it. Okay. So I already have. So first of all, what you will have to, as it says, the principle says that we should aim to reduce coupling between components by introducing abstractions. So let's introduce abstractions in our implementation. So how you will introduce abstractions? Using interfaces, right? So you you first of all, we will create an interface like this. Interface called report writer, and this interface is having one abstract method that is of type void, and the name of the method is write report, and it takes an object of report class as its input. Okay, and then you come here, and this class HTML report writer class will start implements that interface, report writer interface. Okay, this interface. Now you need to override the method that is coming from here. This method, you need to provide body for this method in this class, right? Because you are implementing this interface now. So just add this method. The implementation will be same. So copy it from here and paste it here. Like this. Yeah. And this method is not required anymore. So remove this method. Okay. So what you did is you created an interface called report writer, and now you created a class called HTML report writer that implements that interface, and you provided body to the method that is coming from report writer, right? Similarly, for CSV, we need to write the implementation. So I already have created like this CSV report writer class. That class also implements report writer interface and provides body to the method that is coming from write report like this. So you see the difference. This is calling return to HTML, and that CSV is calling return to CSV, right? This is the difference. That's how you will differentiate when you will see the output. Okay. And now in report generator class, now this report generator class should not be directly dependent on any class. Instead, it should be dependent on the abstraction. So what is the abstraction? This is the abstraction, this interface. So copy this, come here and use a new dependency of this class. Okay. And now this constructor, it should not take HTML report writer. It should take report writer, right? And then because the name of the method has been changed, so you copy this name from here and use it, right? This class is done. And in client, whatever object you will pass, for currently we are passing HTML writer object to this constructor, right? Report generator constructor. So it should print the same output, this output. Let's run it. See, it printed the same output, right? Now suppose client says, don't write it to HTML, write it to CSV file. So you just need to comment this both piece of code. Okay. And what you will do is create a object of CSV report writer. Okay. Like this. And then you pass this to this CSV report writer to this generator. Now, if you run it without making, you didn't make any change into this class, report generator class, but you replace that HTML writer to CSV writer. Then let's see how. Now run this same class again. See, now it's printing CSV. Earlier it was it was reporting to what HTML, right? So without making changes in this class, you replaced that HTML writer with the CSV writer. And suppose in future your clients want even in Excel or Word, what you will need, you just need to create a couple of more implementation classes of this interface, right? And whatever you need, you just use that pass that object in the constructor, and you'll find to so your code is adaptable. Adaptable means ready to accept changes without making much modifications. Even your unit test cases for this class will not fail. This class will not need recompilation because you didn't do any changing into this class. So all these benefits will come if you are following dependency inversion principle and other principles as well. So this is the benefit of, and this is the everything about dependency inversion principle, guys. I hope you understood the concept and you like the video. So if you like the video, please click on the like button and subscribe my channel. And in case you didn't like video, please provide me your suggestions so that in future coming videos I follow your suggestions and try to improve my videos. Okay. Thanks guys. Thanks for your time. Thank you very much. Bye.